Hello, everybody, and welcome to the Automated R&D and Process Circuit Check System sponsored by Philips Ultrasound. On behalf of myself, I am Justin Zakowski, a computer engineering major. We have Shiyan Sun, an electrical engineering major, and Kareem Rashid, another EE major, working together to complete this project. Now, the project objective and summary here, essentially our sponsor produces transducer devices that have to abide by strict design standards as they are used in medical devices. And with this testing, resistance and capacitance measurements must be taken at hundreds of leads within each individual chip. And the analysis of these measurements will determine if the chip is actually suitable to continue in the manufacturing process. Our overall objective of this Capstone project is to automate the collection of the RNC values and to subsequently analyze the data. So the current process is shown here. This is a manual process where you have an employee looking through a microscope at the particular chip. They are holding a probe which is connected to a DMM, and whenever they touch the particular lead they want to measure, they will hit a foot pedal, and that will send the reading to an Excel sheet connected to a PC, and they have to do this hundreds of times for each single chip. So our solution to this problem is to program a Huntron access prober to collect these RNC measurements autonomously. The data is going to be parsed and plotted in Excel file, and the user will be able to visually determine, therefore, a specific problem with a pin. Here's a live image of the Huntron prober in our actual workstation, and I'm actually going to show you some videos we took while in the field. Let me skip ahead a little bit. So here you can see the prober going down on each of the pins. And on the left here, you see the DMM, which is collecting that particular measurement. Our next footage here, you can see it's a much more optimized version. It's going way faster on probing these points. And then lastly, here's a close-up view of what's going on. And you're going to see in a second, this is the software collecting the capacitance measurements. So as for our project outcomes, as you can see, we collect the data of the capacitance and resistance of these chips, and a custom code solution actually parses and plots the data. This is MATLAB style plot. And I'll also write it to Excel as sort of a backup if you need to see the data again, and you can also plot it in Excel. Here's an example of the Excel output. So as soon as the user runs this code that we created, you'll see the columns be created for each of the desired elements. And on the right here, this is a plot that you get capacitance, a capacitance plot, and this is an example of a good chip because there are no outlier readings there. So lastly, for our project impact, this machine actually probes over 400 pins in about 5 minutes, a rate of 80 pins per minute, and this takes like 20 to 30 minutes manually, so on average, it's a 5 times faster process. Not only that, but it saves about $200K annually in labor costs, most importantly, it saves employees from mental fatigue and actual work-related injuries such as carpal tunnel from repeatedly doing the tedious process of probing hundreds and hundreds of leads per day. So yeah, thank you guys so much for watching. That has been our project.